Expression for time period if the spring is in vertical plane. Firstly, traditionally dynamic method. देखो, suppose you say this is the spring and let spring constant is k. If we attach a block of mass m, we all know spring will be elongated. Let we say this elongation is given by x naught. This is the elongation in the spring. In this situation, we know upward force will act, that is kx naught, and downward force is known as the mg. So we can say kx naught equal to mg. This block is at rest. Now we slightly displace the block, furthermore distance x. Situation is like this in the third diagram. Now, what is the net force acting in the upward direction? We all know the restoring force will change. It will be x naught plus x, but downward force is still only weight mg. It means we can say upward force is more compared to downward force, so the block will have the tendency to come in the upward direction. So net force in the upward direction is k x naught plus x minus mg equal to ma. We open the bracket, kx naught plus kx minus mg equal to ma. Kx naught equal to mg. It means kx equal to ma, or you can say a equal to k by m into x. We compare with the standard equation, we will get a equal to omega square x. Omega is given by root k by m. Time period is given by 2 pi by omega. So finally we are getting again the same relation, 2 pi root m by k. So the answer is clear to all of you, 2 pi root m by k. Now we will discuss the same concept with the energy method. Same thing, we take the spring constant x, k. We attach a block of mass m, spring will be elongated, but it will remain at the equilibrium because upward force equal to downward force, and if this displacement is x naught, we will say upward force is kx naught and downward force is mg. Further we displace by distance x. Now downward force will not change, it will still remain mg, but we know upward restoring force will increase. Let it this moment, velocity of the block is given by v, and we know the spring has changed the length from this to this, that is x naught plus x. So we will write the total energy, that is always constant. It will be half mv square is the kinetic energy plus half k x naught plus x square, that is spring potential energy. And at the same time, if we discuss the gravity on this block, the gravity is doing the negative work, and that is given by minus mgx, and it should be constant. Again listen, at this instant the velocity of the block is v, so kinetic energy is half mv square. From this, we attach the block at this point, and block is moving in the downward direction, potential energy decreasing, it is minus mgx, and spring changing from this point to this point, so total energy of the spring is half k x naught plus x whole square. We differentiate it with respect to time, half m 2v into dv by dt plus half k to x naught plus x, then x naught is constant and this dx by dt minus mg dx by dt equal to 0. Then we cancel the two. Then one more thing, if it is okay, this is the velocity, dx by dt is velocity, this is velocity. Now what we can write, m dv by dt is acceleration, plus 2 cancel, we get k x naught plus x minus mg equal to 0, and kx, we open this bracket, ma plus kx naught plus kx minus mg equal to 0, kx naught equal to mg, again we are getting ma equal to minus kx, comparison equation, a equal to minus omega square x, omega will be root k by m, time period is 2 pi by omega, so it is 2 pi root m by k.